Yes.
Today, let's begin with the Docker. Here we will be talking about like what is Docker, why you need Docker and all. Docker as a containerization tool. To understand this, let's take some use case. So what is Docker? Let's take a simple example. Suppose you have an app and this app needs, it has some specifications like it needs Ubuntu 16, okay, Java 8, Tomcat 11, so on, right? This needs all these specifications. So let's suppose there are three clients or users interested in using this app, okay? Client one has got completely Windows environment with no Java, with no there is another client, client 2, who has got some, like Ubuntu 14, Tomcat 9, and Java 17. Okay. And there is a client 3. Okay, client 3, where the user, where the client has got exactly Ubuntu 16, Java 8, Tomcat 11, right? So we need to provide them with that. It's very easy to provide this client 3 with the application, correct? I can provide him with the app very easy. How about this client 1 and client 2? How to provide them with the app? Some of them may don't know how to upgrade their operating systems. Some of them may not be interested to do it, isn't it? They might have other configurations, other applications as well. They cannot modify their infrastructure for this app, right? Let's say this is some gaming app. So how to handle client 1 and client 3 losing the without losing them. It's not that you provide the app only for those who provide, who, what do you say, who has the supported infra, right? We should be able to provide the app for all of them who are interested. So how to provide others with the application? Yes. How to provide these clients with the app?
We use Docker images,
What are Docker images?
like which are already in the Docker.
What is Docker? Where is Docker? Which are already in Docker means?
Docker is the container.
Mm-hmm. Okay.
Which have all these files in the form of images, like Java, Tomcat, and all.
Like what exactly it is in the form of image means what do you do with that? How to use it? What is
Packing,
inside that
packing,
container?
packing up of all the library files and necessary var files
Mm,
according to the version and creating an image is called Docker image.
mm,
And if you run that image, we will get a container.
mm. So then how is it different from a machine server?
See here, only necessary library packages will be packed. So if you consider it in a VM, there will be kernel, file system, and everything. So here, Docker images will use the base kernel of the OS.
So
Along with that,
you
it will
okay.
run.
So only Docker containers are the solution. Without containers, how are we doing it? Only containers are the solution. Docker is a solution.
Containerization is the solution, not only the Docker.
So what else I'm asking apart from Docker, we did not start Docker at all. Okay, I'm talking about why we came to Docker. So is there any other solution to this or is it only Docker? Any other solutions to handle client 1, client 2?
So a solution like we can install VMs just all.
Actually,
No,
there comes the point of virtual machines, right? So you create a virtual machine, okay, create a virtual machine which is having this Ubuntu 16, put Java 8, Tomcat 11, share the VM to them. That works. That's what we are doing till now. Right? That's a traditional approach, and that's the approach we do. Similarly, this problem statement can also be solved with something called containers. So what are containers and what are VMs? Both does the same. Means both can be solution to this problem statement. Okay, both does the same. So then you may be asking, do you mean they are same? They are not at all same. They are completely different, right? They are not same. They are completely different. They have different architecture. They have different performance as well. Then let me tell you, they were not at all same, but they follow the same concept of virtualization. They follow the same concept of virtualization. Yes, both follows the same concept of virtualization. Then what is the difference? Architecturally, they are different, performance-wise difference. But you can remember here, in VMs, virtualization done at the hardware. Whereas in containers, virtualization is done at the OS level. Okay, 1 second, give me a second, please. So VMs follow the concept of virtualization. Virtualization is happening at the hardware level here, whereas virtualization is happening at the OS level in the containers. Right? What is meant by this virtualization happening at the hardware and OS level? We will talk about this statement. Here you can understand virtualization done at the OS level is called containerization. Okay. So this is called virtualization done at OS level is called containerization. Containerization will be next step to virtualization. This is next step to it. It's not replacing it, but it is next step to it. Right? Got it? So what is meant by virtualization? What is meant by containerization? Like how this is performing, we'll see. Okay, but so virtual containerization is next step to virtualization. And here in containerization, how do you achieve this containerization? So Docker is a tool with which you achieve containerization. Means to install any, to start any containers, to create any containers, you need Docker. Docker is a tool, a containerization tool, or a tool with which you can achieve containerization platform, right? So that's what is Docker. Means it's a tool. Like let's say, okay, I want to create containers. You will install Docker and start Docker, right? So that's about the Docker. Now, we will install Docker and we'll start working with it. But before that, let's see the architectural differences between VMs and containers so that you can understand actually like when to use VM and when to use a container. Good to go? Any questions here? Any questions?
No.
Are you seeing the screen?
Yeah, we can see.
Yes.
Okay. Okay, so now let's talk about the architecture. So, yeah, see here, this is the architecture of VMs and this one is for containers. First, let's understand the architecture of VMs. Okay, here if you see,
Not able to see screen.
We're not able to see the screen.
all right. Can you see that now?
Yeah, got it.
Yes.
So this is the virtual machine, right? There were three VMs here if you see. Yeah. And if you closely look into each VM is having something called guest operating system, means its own operating system, which sits above the host operating system. Here the infrastructure is our like our hardware, and the host operating system is our laptop, like my Windows 11 hypervisor. What is a hypervisor? What is a hypervisor?
That's a virtualization software.
Hypervisor is a virtualization software, means with which you can create a VMs, with which you can launch, with which you can work with the VMs. So this is a VM which is having the guest operating system. Guest operating system like this might be having a something like its own operating system, and then the binaries and libraries means, see, you want to run your gaming app, so your gaming app needs some dependencies. Only those binaries and libraries will be installed here. Right, that's what is the guest operating system, binaries, libraries, and the app itself. So this is what is a VM. VM will have its own operating system, the binaries, libraries, and the gaming app. Right? So, and also it just works like a normal machine because it has got its own operating system. It can shut down, it can boot, everything it can do. But it is definitely very heavy and huge because see, it is having its own operating system. And the resources for for each of these VM is allocated from the host operating system itself. Right, means let's say they are consuming some resources, isn't it? Every VM needs some resources. So each one of them will consume some resources which will be assigned from the your host operating system only, means from your main operating system like your laptop, right? That's what we were talking in the beginning. They consume the resources, so let's not put the VMs on our machine because this is a VM. These resources are allocated from the host OS only. Am I making sense? From here only? And let's say you assign 10 GB. Out of it, 8 GB will be consumed by this guest operating system only. Majority of the resources will be consumed here. Okay, maybe 2 GB for the app and the dependencies. Right? So they are very heavy, huge. They consume lot of resources and they work really slow because they have to start, shut down, which are very huge. Same is the case with every VM. So let's suppose you assign 10 GB for every VM, 30 GB. Again, to process all this host should have at least 40 GB, right? And how many VMs you can put depends on how much of resources you have, correct? Yeah. So if you put too many VMs, it may degrade the performance. Correct? So you should be careful launching the VM. So if something goes wrong or if something is corrupted or something got crashed, you have to take care of their backup and all, backup recovery. So a lot of maintenance overhead. So that's why instead of using these VMs, we were going with our own VM. In the sense, sorry, we are going with the VMs on AWS. Correct? Yeah, so that you don't have all these maintenance things. Everything will be managed with a cloud provider and you just use them whenever you need it. Understood? Any questions? Any questions from anyone on this architecture?
But we are not using this architecture, right? As you mentioned, we are currently using that, virtual machines on the AWS server, right? AWS, no?
Yep. Yes.
So how can we compare with that model with this Docker?
You understood this architecture?
Yeah, this one is fine.
Now we'll talk about the architecture of Docker. So this is the architecture of VMs, and here you have to remember one more thing. Here, to work with these VMs, your hardware should support. Means basically, your laptop, there is an option called virtualization technology. You should enable it. Only once this is enabled, okay, you can run VMs. Otherwise, you cannot run the VMs. Right? That's what you have to remember. Basically, that will be enabled by default, but if not, you have to go to the BIOS and enable this virtualization technology. Clear with the architecture of VMs, everyone?
Yeah.
Now let's talk about the architecture of containers. Here, this is the operating system. So let's say again my laptop, I'll install Docker, Docker engine, right? Docker engine is nothing but like Docker daemon, Docker engine, whatever you call, install Docker and start Docker. Then you can start the containers. And these are the individual containers. If you see the containers here, here if you see the containers are not having its own operating system, correct? Yeah, they are not having their own operating system. Then how do they work? Yes, they can again start, run, do everything. Right? They can do everything like a normal machine because they use the host operating system. They don't have their own operating system, but they use the operating system of the host. They use operating system of the host. Means they don't have their own kernel, they'll share the kernel of the host. Right? And here, if you see, this part is missing, isn't it? They don't have their own operating system. They don't have their own guest operating system. This part is missing. So what is the use of it? Advantage? They consume less resource because whatever resources you allocate from the host, they consume like a majority of the resources consumed by the OS. But here they don't have their own OS. Hence, you can consider them like they are light, they are very faster, they can be created on the fly, created very quickly on the fly, they run very fast, they consume very least resources. And here you don't need to go to BIOS and enable virtualization because virtualization is not happening at the hardware. This kind of sharing the kernel is nothing but virtualization happening at the OS level, which is called containerization. Right? Understood? So the advantage is you create containers on the fly very quickly, very light. You don't have more resources, very less resources. You have less CPU memory you have. You can go with the containers. Got the point, all of you? Differences. This is the
Right.
performance difference. Your hardware need not support running the containers. It's happening at the OS level. Yes.
Yeah, Preeti. See, the operating system has a kernel, and these containers shares the contact the it uses operating system kernel. But what Docker engine does it have a kernel on its own?
Why should Docker Engine have a kernel? Docker Engine is the software which allows running this or creating these containers.
Then it does only orchestration.
Orchestration. It's a software. You see, you want to run Java application, Java should be installed, right?
Yeah.
Similarly, to run containers, you need to have some containerization tool installed, which is Docker. Here, Docker, there were so many other containerization tools like you have Docker, Rocket, Creo, Containerd. These are all different containerization tools, but you hear only Docker because Docker is very famous and very widely used. Any more queries? Everything clear?
So, Prati, for currently, see, as I mentioned earlier, right? Currently, we are not using this traditional way of visualization, right? Instead, we are accessing virtual machines in the AWS, right? Where they're not sharing that, no, host operating system, right? It's not our heavy, you know.
Come again, please. They are not sharing more operating systems.
No, the host operating system. So, so how can I'm just thinking, how can we compare that, you know, the current way of working, right? That we
Again,
are
this is the
creating.
same architecture we are using. Same architecture, but this is now this architecture is on the AWS. Means instead of having your own operating system, your own hypervisor, your own containers, you are using the VMs of AWS.
Okay.
These are the VMs we are using, but here they are not running on my laptop or they are not running in my own data center in my company.
Okay.
Rather, these VMs are running on someone else's data center like AWS data center. EC2 instance is nothing but a virtual machine which is running on AWS data center.
Mhm.
This is an EC2. This is an EC2 which runs on AWS data center, not on my laptop or my own data center. Again, the same architecture. Of course, that's a bare metal architecture. If you remember, I have shown you two types of architectures. Bare metal architecture, where they'll have huge servers. On those servers, you have these VMs. You are just starting them and connecting to them and using it.
Correct.
Again, same kind of virtualization concept there.
Yeah, Preeti, in the virtualization software or in AWS, we can run multiple EC2 instance with different operating systems. But
Hmm.
in this infrastructure Docker, can we, if the host operating system is Windows, can we run containers with multiple operating system, Windows, Linux, Ubuntu?
Yeah, let me tell you. So let's come back. This is my laptop. I'm having different VMs. Let's say my laptop is having Windows 11. Can I have here Linux VM? Yeah. Can I have here, let's say a Linux one? And then can I have here Windows, some other version, some Windows server? And can I have some other Linux version? Let's say this is Ubuntu, this is Debian. So which of them are possible?
All are possible.
All
All
are
are
possible.
All
Why,
are
why
possible.
all are possible? How?
Everything is different OS, and hypervisor is providing the resources for each OS.
Through hypervisor, you are providing resources. Hypervisor is not providing. Through hypervisor, our main operating system provides the resources. Okay, yeah, correct. So you can have any VM of any operating system because every VM has got its own operating system. So yeah, you can handle anything here. So now let's talk about these containers. Can I have, okay, let me talk about this first. So I have my operating system is Windows 11. Actually, initially Docker is developed for Linux systems, but now you have Docker from Windows 10 and above. So let's say I have installed Docker on my laptop. So that's a Windows one. Now, can I have some version of Windows container here? And let's say some other as container 2 is some distribution of Linux. Can I have it or not?
No, you cannot have.
Why?
See, Linux is operates with a different kernel. Windows will operate with a different kernel. So Docker engine is going to share the kernels, resources, everything. So in this case, Windows host cannot run Docker, Linux Docker image.
Correct. Because they share the kernel of the host. If it is Windows kernel, a Windows container can share it. A Linux container cannot share the kernel of Windows. So you can run only Windows. Different versions are fine, but only Windows. Right? But let's say I still want to run Linux. What you can do on this Windows, you can install on this Windows, you can install a
VM,
hmm,
Linux VM. Then on top of that, you can install
you can have Linux VM. Here you can install Docker. So now above this, okay, I can have any Linux containers because this becomes the host for, and that's called Docker host. This terminology is important. That's called Docker host. Docker host means the machine where Docker is installed. This becomes the Docker host for it. Okay. This becomes a Docker host for it. So yes, it can run. Whereas this is the Docker host for them. Got it? So basically, which containers you can run depends on the host operating system. Host means Docker host. If your Docker host is Windows, you can run only Windows containers. If your Docker host is Linux, you can run only Linux containers. Are we good?
So instead of installing this Linux VM, we can have a different Linux host itself and separate them in a different cluster VM, right? In the sense infrastructure.
On the same VM, you want to have separate Dockers? Is that your question is? Hello?
Yeah. In this, say, in the architecture, infrastructure, there is next is operating system. In the operating system, I have a Windows operating system.
Hmm.
Similarly, I can have another host which has a Linux operating system. There, I will install Linux and separate.
Another host means operating system. You have Windows operating system. On that, you will install Docker. So another host, you want to install another Docker there?
No, not there. Separate infrastructure, separate VM itself.
That's what we were talking, right? You can.
No.
See, if you are having an operating system, if you are installing Docker there, right, you can run Docker containers if that operating system is Windows. If the operating system is Linux, you can run Linux containers. If you want to run another Windows containers, you have another system and you do the same. Okay, so containers are like light and they can be created and consumed, like they consume less resources, so they can be working very faster, right? So this is the architecture of VMs and containers. This is how they work. Okay. So clear with this architecture and the justification, what is containerization, what is virtualization, clear with this everyone. So when you understand the architectural differences, you can understand the difference, you can understand the importance. And also see, it doesn't mean that, like I already told, containerization is not replacing VMs. It's a next step. Means because you are not completely removing the virtual machines. You are running containers means where are you running them? You are running those things again on a Docker. Again on some VM, isn't it? So your containers will be running again on some virtual machines like EC2 instances, okay, or any physical server. So it's not replacing it, it's a next step to it. Got it right, everyone?
Yeah, Preeti, this application and binary libraries on top of Docker engine, what are those actually?
Those are like we were talking about the dependencies, right? Your application needs Java, your application needs Tomcat 9. Those are the dependencies, binaries and libraries of the dependencies.
Along with application.
Your application. Yes. And let me tell you, I believe didn't anyone have the question like when I said, your container will not have any operating system, but how come I say Linux or containers or Windows containers? We discussed that they have no container, they have no operating system. Yeah.
Sorry, I didn't understand.
See, I told you that Windows, containers doesn't have their own operating system. Then how come we say Windows containers and Linux containers?
No, it's only on the basis of the operating system where it is running.
Yeah, it will just have the, when I say Linux way containers means it will just have the minimal operating system. Okay, the base operating system, but not the full-fledged operating system.
Okay.
Understood? Just the base, minimal. Okay, minimal, like binaries and libraries of the operating system, not a full-fledged operating system. Okay. All right. So now that we understood the architecture, let's get into and understand the use cases. Like say if you want to run multiple applications, means I have DB, I have PHP and all, I have to run so many applications, better you go for VMs, right? And containers, if you have multiple things, actually the thing is you may have multiple services, multiple applications. One container or one application per, one application or one service per container is the best practice, right? Meaning you have to run, like when you have too many applications, always one container, one application per the container. Of course, you can run many, but that's a best practice and that's how we use it. Okay, and portability. VMs, working with VMs are platform independent, isn't it? You can have any operating system, whereas that's not the case with containers. And obviously, VMs consume a lot of resources. Again, that's not the case with containers. They are lightweight, they don't consume many resources. Security wise, yeah, VMs don't need root user privileges, but containers need root user privileges to execute. Those are some of the differences, and those can be handled in different ways. We will be talking about those implementation as well. And yeah, see, once Docker came in, the way of development, the way of deployment got changed, which brought the DevOps revolution in DevOps. That's what we have learned, like Docker, everything. Am I audible?
Yes.
Yes.
Okay. So, build once, run anywhere. Do you remember in the beginning classes, I'm telling you, the way developers were packing their application also got changed, right? Like, see, earlier they used to share the WAR file directly. Yes? They were sharing this WAR file to ops teams. Ops teams will install all the dependencies on the VM, get the VM ready, and run the application, right? But now what they are doing, developers are not sharing this WAR file directly. We have generated WAR file in our pipeline. Do you remember, everyone?
Yeah.
Yeah, so they were not,
Yes.
they were containerizing it and sharing the Docker image with the teams. So as a DevOps person, I need not struggle or worry about how to install Java, which version of Java and all. Developers will pack that Java application, everything, and share that with me. Got the point, all of you? Yeah. So the way of development also changed. Let's say you are a developer, you still want to continue as a developer, you like development, but still you need to know these DevOps tools, because the way how they deploy, it means how they share the application also got changed completely. Understood, everyone?
Yeah, this is next level, right? Because still there are some companies still using the old methodology. But if they want to come to this DevOps methodology, they have to follow this pattern.
Yeah. This is the right approach of containerizing or implementing the DevOps. That's what many companies say, they are implementing DevOps, but still they use the old fashion of deploying the application. It is still there in many companies. That's what it's say DevOps is implemented, means it's not like 100% strategies are implemented, but this is what actually is. And also some companies are doing this containerization, but still there are teams where developers don't know how to containerize it. DevOps team is doing it. They create Docker images for them. There are teams, there are companies where developers will create Docker images. It all depends on the resources available, the feasibility, and so many other factors. It's not that every company is doing it. Still, there are companies who are using shell script without using automation tools. What do we say? That's how it is. All right. So the way of development, the way they were packing their application changed. So build once, run anywhere means they can just build this Docker image once, which reduces or which removes all the overhead for other teams to struggle with the underlying dependencies. So they are bothered about only building the containers and the libraries, app, and data dependencies. Similarly, this also brought revolution how they were deploying. Like they give the image, they run this image on any environment, be it dev, prod, or whatever. Application runs seamlessly in any environment. Okay. So yeah, this is what. See, earlier you might have seen that application works on developer's machine because developer is using Java 8. Let's say I'm a DevOps person or else I'm a tester. I'm testing it. It's not working because I'm using Java 11. You have to talk to the developer, identify the issue, fix the issue, upgrade Java to Java 11. But after some days, somehow Java is automatically downgraded or else further upgraded to Java 17, which is not compatible to our application. Do you remember we faced these challenges in our course? Have you faced, how many of you faced the same exact scenario?
Yes, I
Whenever you are
Yeah,
packaging, MVN package doesn't run because Java versions, you have to fix it. You fix today, it's working today, tomorrow it's not. Many of you have seen that. That's the reason I have given that particular task and asked everyone to do. Do you remember that? Yeah, MVN package, you are getting error. MVN compile also might be errored out if it needs specific version of Java. Your application dependency, right? So how to overcome this? That's a huge nightmare. If you remember, it's a big daunting task in the real world, right? Earlier, if it is not working in production, they would spend some sleepless nights, identify the issue, troubleshoot it, fix it. Then again, it might be repeating. Am I correct? Have anyone faced these issues in your work, in your projects? This is the
yeah,
way
it is
old approach.
traditional
Ah,
deployment and all.
correct. Yeah, you have seen it, right? So these are the challenges. But now what they're doing, they're not just simply giving that WAR file. They'll pack this WAR file along Java 8 because that needs Java 8. Whatever Tomcat, they'll pack it, give that container. You may run that container on any server, it works seamlessly, and any upgrades happen on the server, they don't affect the container. Understood? Yeah. So deployments became seamless, faster. You don't struggle with those underlying dependencies as a DevOps person. And that's why we hold that pipeline there with var file. After that, we learn this containerization thing and we'll add the stage of containerizing the app. It would be generally done by developers, but we will also should know it because like I told you, right? Different companies, different projects, so many factors. You never know what you have to do. Are we good with this page? Understood how Docker brought revolution in the way of development and deployment? Good to go?
Yes.
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 So now that we understood the importance of Docker, architecture of Docker, now let's get into understanding the components of Docker. So till now I'm talking about, okay, there is an image, I'm talking about Docker container. But how do you get the container? You get the container from another component called Docker image. Means till now I'm telling developers will create the container, share the container. Actually, they don't share the container. They will share the image. Image is a static file, a read-only file. They share the image. Okay. Means they'll create the image. But how do they create this image? From another component called Docker file. They'll write the Docker file. Okay. They'll build the Docker file. Okay, they write the Docker file, they build it, they get an image. They run the image, they get a container. Means container is the running instance of the image. Right? Like, do you remember something like .over file for a VM? Do you remember that? Like if you want to run a VM, there'll be a .over file, you run it, you get a you start a VM. Means your VM will be running. Similarly, container is a running instance of the image and image is a static file, a read-only file. You run it, you get a container. Container is a running instance of the image. Imagine you container like a VM, but not a VM. I told you what are all the differences it has got. So Docker image, so many Docker images are already there for standard configurations. All the images are stored in a place called registry. Registry is a storage place of images. Docker Hub is one such example of private registry. So developers will create image store here, or else there were already images available, so many standard images, anyone can download and use it. But what if you want to create your own image, right, with your own custom configurations for your enterprise applications? So developers will write the Docker file. This is the Docker file. So Docker file is a text file. Okay, it's a simple text file where you write some Docker instructions. And when you build the Docker file, you get an image. You may use images which are already there on Hub, or else you may create your own image. Even you can store it on Hub and share it with others. Other teams will download and start a container from it, means your application is running. So these are the different components one should make a note of. Docker file, Docker image, Docker containers. Okay, we will be looking into each of them uh, in depth. Is this clear, everyone? Is this diagram? Just the components, introducing you the components.
A Docker Hub is a public or private registry?
Actually, it's a public registry, but it can also be used as a private registry by having a paid account. Okay, but even then you can be used as a private account. Many companies, particularly banking institutions, don't prefer it. There are private registries like a GCR, Google Container Registry, ECR, Elastic Container Registry from AWS. Every cloud has got its own container registry like Azure Container Registry and so on. Even Nexus can be used as a artifact store for images. JFrog can be used. And again, companies may have their own private registries. Yes, to store the images. Registry is a storage place of Docker image.
Nexus is a hardware device or how?
Storage place of your artifacts. You generate an artifact, you store it, you download from it and use in the next stage.
Okay. So simple storage devices. In that
Not device, storage application, Nexus, JFrog,
okay.
ECR. I'll show you ECR so that you'll get an understanding. I'll also show you anyway Docker Hub. So these are,
easier
see,
about
don't deep dive into them. We'll have a separate section on each of them. Just have an overview, Dockerfile. From Dockerfile is a basic or the fundamental unit. From Dockerfile, you get an image. From image, you get a container. You may store the image on Hub or anywhere so that it can be used to launch a container. Understand this flow. Good. Still any questions? So this is what Docker image. What is Docker image? What is present inside? What is the base image? We'll talk about all of this architecture and all again. First, let us install Docker and start working with Docker. Okay, let me install Docker. You can use any machine, preferably use some EC2 instance. You can go with the same Jenkins server. Okay. Let's connect to it. Let us install Docker using simply yum install command, yum install Docker. Okay, you have installed Docker. Now start Docker. Okay, done. Now the first command is Docker images. And this machine is the Docker host, right? Docker host is a machine where your Docker is running. This is your Docker host. When you do Docker images, it will list the images, but there were no images as of now because it's a new Docker host, right? So nothing was displayed. Okay, fine. I don't have any images, but I would like to run some image. We discussed, right? You run the image. There is an image called Hello World, a sample or the basic image I'm running. But is this image available on my machine?
No.
No. So if I run this, what happens? Will it give me an error or what happens if I run this?
It will pull from public and run, public
It
registry.
will first search locally. Here you can see it's searching on the same machine. If it doesn't found, it's pulling from library hello world means it's pulling from Docker Hub. Okay, where is your Docker Hub? Just go here, hub.docker.com. This is the default Docker registry, a public registry. It will first search locally. If it doesn't find locally, it will download it from the hub. See, this is the Hello World Docker official image. Okay, so it will download from here. That's what it was showing. And it will start a container. And this image is made in such a way that it will show this welcome message. That's how that image is made. So it was displaying the welcome message, but as it has downloaded the image, yes, you can see here. Earlier we don't have, but now it has got it. It will have the image name and it has created a container, right? You can see the container with the Docker PS. Docker PS will show only running containers, but it has created a container and the container got exited. So PS minus A will show all the containers, including running and exited. See, it has created but exited. Why exited? That's the next story. We'll learn it. See here, every container will be generated with alphanumeric ID assigned by Docker daemon. You can't remember that, so it will also assign some random name, quirky hello, some random names will be assigned by Docker daemon. What if I run the hello world again? What happens? See, this time it's not saying unable, it could not find locally. It found locally, so it doesn't download, it used it and again started. See, you can have an image and you can have any number of containers from the same image. See, another container 536 from the image hello world. It's a vibrant ride. So as many number of times you run the image, those many number of containers will be created. And each time you run this, a random name will be assigned. If you want to assign your own name flag, C1. I want to give container name as C1. So image will be only one, but if you see the containers, yes, this time one more container C1. Understood? Okay. So
And next time we can execute same C1 by using the flag name, right?
different container name. Container already there. You can't create container with the same name.
Yeah, same container can we not restart or start it?
You can start it.
Oh, okay.
Okay. So only one image out of which I have started so many containers. So I have C1, C2, Vibrant, right, and so on. Okay, so many containers are there. All right. So now that we have seen this, and if you see image name, you see hello world, right? You may search your Docker Hub this way. You go here, search, let's say I want to search for some Ubuntu or anything, you may search here. Like I want to search some images of Ubuntu. Okay, there are different things of Ubuntu is there. You may search here, or else you can search from the CLI as well, like Docker search Ubuntu. Okay, see here you see the name and the description. Here OK indicates their official images. But how do you understand this image name? Ubuntu Prometheus Alert Manager. How do you understand this? To understand the naming convention, you need to understand how images are stored exactly. Let me tell you. I told you, right? Images are stored in something called registry. Here in our case, it's a Docker Hub. Inside the registry, they are stored in something called repository. Repository is a storage place of images. It's like a folder to keep like images. Like let's say I have so many images related to Ubuntu, Ubuntu 16, Ubuntu 22. So you may create repo called Ubuntu. In this, actually images will be stored as tags. Tag, that's a tag. Okay, like Ubuntu 22 means we'll put tag name as 22. Tag name indicates exactly what is inside. So this is the hierarchy how images are stored. And the naming convention would be registry address / repository :tag. Okay, and if it is Docker Hub, registry address. Repository name is, in our case, we did hello world. And I did not put tag name. If you don't put tag name means it will consider latest. That's why earlier I was simply saying hello world. If you don't put registry name is by default Docker Hub. You don't put tag means by default latest. So I simply said hello world and it has pulled, it's a repository name. It has pulled it from Docker Hub. See here. Okay, that's actually repos name because I did not put tag name, it took latest tag. Understood the naming convention? Similarly, if it is a unofficial, means you may have your own images. Again, the format will be registry, repository, username, :tag. Okay, registry is optional. If you don't put registry name, it goes to hub, repository name, username, and tag name. That's a hierarchy how images are stored. Either it is an ECR or GCR or whatever private registry, this is the naming convention one should follow.
Could you repeat that username part?
Registry / repository name / username. If it's a private images, you should put your account username.
Okay.
Here, if you see, I have logged it to my repos. You can just create a free account and sign in. This is my username. Here are my repositories. Can you tell me how many repositories do I have?
4.
I have 4 repositories, right? See, out of which one is private repository. In the free account, you can create private repository, one private repository. You can create repository from here. See, private is not allowed because I have already created one. If you need more private repositories, go for a paid accounts. Companies will have paid accounts. Okay. But yeah, I have one. So total 4 private repositories I have. If I go here, how many images are present in this repository? One tag means one image. Tag name itself is Docker file. How many images this repository has got?
4.
4. And this is the command. Do you see here? See, username, this is the username, repository name, tag name. Understood what I'm saying some time back? sorry, username and repos name. Here, one correction. It is actually registry username repository tag. Right? This is how. See, it's not having registry address because it's Docker Hub. So by default, it will have Docker Hub. Username, repository name, tag name. Tag name can be PHP app, web app, B2. I have 4 tags, 4 images present in this report. Clear, everyone? And now let's pull some public image. Let's say I'll pull this deploy v1. DevOps, no, okay. Ops trainer, deploy v1. You can download this because it's a public one. Anyone can download it. Okay, so it says newer image downloaded images. Yes. I want to push it back. Same image I can't push. Let's say I want to create a copy, or else I want to push the same image to some other repository. Let's suppose I want to push to this repository, my image. How to do that? This is the image name. First of all, you should create a copy of this image with the same name. Docker tag. Copy of this image means first give the existing image name. Yeah. And the one I want to push is my image colon. I want to do like this. You understood? Why I'm giving my image this repository name. Okay. So what you have to do is you have to create a copy of the same image with the new image name wherever you want to push. See, you may want to push to different locations. Your image name tells everything. Image name explicitly gives the path where that image is stored. Image name will have the complete path and address. You want to push here means you should have an image with this name. So I'm creating copy of it with this name. Right? Got it? Docker images. See, this is the one. Now, push pull commands are same. You may push to Docker Hub, you may push to ECR, but image name will have the address. So accordingly, it will push either to Docker Hub or ECR or wherever it is, whatever it is. Now it should go there. Understood? But authentication, because see, pull you can do, but push you need authentication, Docker login. Okay, so you can see here login succeeded. Your credentials will be stored in a file called config.json. You see, in this home directory, a folder called .docker will be created by default, a hidden folder. In this, you'll have config.json created where you have your credentials stored. Now that I have authenticated, I can push my image. What are those layers? What is happening at the back end also? I'll explain as we go by. See, earlier there is one tag, but now if you check, where did I push DevOps trainer, my image? 1 minute. Oh, see, I pushed deploy v1. It's already there. So I have to push. See, okay. Let me show you first images list. That image should be present. This is the image. Image should be present here first to push. So that's why I have tagged it to create an image, which is a copy of the earlier one. Okay, now this is the one I want to push. Okay, it says it has push. Now let's check here. Yeah, do you see V1 pushed a few seconds ago, 7:06 a.m. Right? That's how you do a push, pull. Clear? Understood? Any questions?
This Docker tag only I couldn't understand because why
Kalpati, what is
Docker tag is, suppose, say you want to push to my image repository, means image name should be like this, right?
image name should be the target which we are pushing to, that repo name should
Correct.
come, right?
Correct. But how do you get that image with that name? You created copy of existing image with this name. Tag command will create a copy of this image with this name. So you have image with whatever name you want, target name, destination name. So when you push it, it goes to my image repo. But let's say you don't tag it, you still try to push it. As many number of times it push, it goes to deploy repository, not my image repository.
Okay.
So you tag it not only to this DevOps trainer, some other account you may push, you may other registry you may push, but you should tag it in such a way which will be prefixed with that registry address. Because it's Docker Hub, no registry address. Otherwise, it should be prefixed. So let's say I want to push the same to ECR. I will tag it with that name, which will have ECR address / that repo name
Repo.
/ tag name.
Okay.
Then I push it, it goes there.
The
Otherwise,
tag name, yeah, the target tag name can be anything. Suppose here I just loaded V1, so I can name it anything which I want, right?
any name
Because
you can give tag name. What name you want to store the image? Tag is the actual image. This is the repository.
okay, got it. Yeah.
And any other questions?
Yeah, if tag
If
name
you
is there, we can
change
push
the
to public
One
or
after the
private.
is one by one. Tell me.
Yeah. If tag name is there, we will give the tag name. We will push the images to public or private repository, both, right?
Yeah, you can
Okay.
push with authentication.
Okay.
Yeah.
it's like, can we change the tag name and like push to the same repository like DevOps trainer deploy one?
Like I said, you can push to same one. You can push to. I don't want to corrupt this repository because I have some useful images here. You can. Let's push to this one. This is a dummy repo. I can mess it up. Means I can have a unused, like unuseful images also. Okay. Now if you push to the same repo, you can. Right? Pushed. Earlier only V1. To deploy repo also, you can push if you want. Like I said, that's a useful repository. I don't want to put replicas there. Yeah, do you see? 7976. Clear?
Yeah.
Your image name tells everything. Which repo it should go, which registry it is present, what is the tag name. Push pull commands are same whether you push to ECR or GCR or any other private registries tomorrow. Your organization may have its own private registries, in-house registries. Push pull commands, the concept you should know. Not that you say, oh, I worked only with ECR registry, I don't know how to work with Google registry. That sounds silly. Got my point, everyone? That's why, that's the reason companies, I told you, right? They were not looking for, AWS, we have AWS infra, AWS, then only you come in. No, they have AWS infra, you may be working on Azure, still they can have you. In the beginning, many are asking, there were so many options. Job openings for Azure. Do you teach DevOps, Azure DevOps, or AWS DevOps? There is nothing like Azure DevOps or AWS DevOps. Like how it sounds silly, the question of I know only pushing images to ECR, I don't know pushing images to GCR. That's how it is silly. Yeah, that's the actual truth. Any more questions? Do you agree with what
So
I'm saying as you have
yeah,
seeing the things, right? Once you know pushing an image to one registry, it's the same with anything else. It's not that you learn every cloud or every where you have to push the image, you have to learn. But anyway, like for reference to get more idea, I'll show you on ECR. But you should be able to do it for GCR or anything else tomorrow. Yes. Tell me, please.
so for our practice, we can pull these files from your repo, from the public, and
Public ones you
we
can
can,
pull. Public ones you can pull.
so we can push it to our ones.
Yeah,
Like
you see,
like
public,
if
yeah,
we
you can.
create a Docker.
Yeah. See, from my public, you pull the images. You
Mhm.
tag it with your registry address and all. You push there.
Yeah, like that means like we can practice like pushing and pulling these Docker images.
Yes.
And how to start these images? Like
Start
it's
means
not,
run. We
yeah, how to
see,
run. Yeah.
okay, before we run, before we get into the images, there are many things. We will go step
Hmm.
by step.
Okay.
See, I just want to convey you the point correctly. So I was talking about like this is as simple as that. It's not to get someone offended, right? Like take it in the real way. But what companies are looking for, what you need. That's my intention of telling. That's all. Okay, and also, yeah, we will also look into doing it from ECR. Like we were using EC2, right? Now we'll also look into ECR. If you go here, okay, you search for ECR, Elastic Container Registry, like GCP, Google Cloud has got Google Container Registry, Azure has got Azure Container Registry, Nexus, Artifact, whatever it is. Okay, these can be used like a private registries. So here, if you see, yeah, you can create a repo here and you can tag accordingly and do that. Do you want me to continue with this or shall we take up this tomorrow? As we have done many things, I think we can take up this tomorrow fresh, right? First, practice pushing it to hub, right? This command may be confusing. I totally understand. This might be a bit tricky for you initially, but try to understand the concept. Docker will be very easy. You can push to any registry, any repository. You understand why it is failing and all. Try to listen the recording once again. Okay, still if you have a question, you can post it there, right? Once I'm available, I would be responding or else team will be responding, right? Try to do this hands-on, understand this thoroughly, then we'll push to ECR tomorrow. Yeah, we'll push and pull from ECR tomorrow so that you will be ready to work with any registries. Are we good?
Yeah.
Yeah.
Yes.
Yeah.
Pretty in related to Jenkins.
Mm.
Are we all done with Jenkins topics, or do we still have anything there?
Jenkins will be throughout the course. Okay, till
Okay.
Ansible will have Jenkins. Pipeline should be completed, right? Is our pipeline completed? Only till package we did. A little part in the CI we did. Okay, we
Okay.
have to get
Deployment.
in, we have to get into CD part. We have to get into provisioning the infrastructure with Terraform. First, containerize it with Docker. Then deploy the Docker containers on EC2 servers. Then deploy the Docker, because there would be different deployments. It could be deployment to on-prem physical servers. It could be deployment to in VMs on cloud, or it could be deployment to clusters, Kubernetes clusters. Again, cluster might be on AWS or GCP or on-prem. So many ways you can deploy. So first we'll containerize it. That's going to the next stage. Then deploy it directly on EC2. Then deploy it onto Kubernetes cluster. Then provision the infrastructure with Terraform. Then configure the infrastructure with Ansible. These are all the stages will be added. Pipeline is just started. That's all. Jenkins is completed means topic-wise, content-wise completed. Okay, but we'll be using it.
Okay, but yeah, but see, there are some companies they are also integrate.
Tell me, they integrate?
They integrate code quality tests. Some Sonar Cube. What are those? During the before deployment, they test the vulnerability of the code and do the scanning and any fixes. Uh, they fix those vulnerabilities. Then they so that Sonar Cube part, are you covering, or it's by default it's
In
part of Jenkins?
organizations, okay, or else like in any company, anywhere, there will be hundreds, thousands of pipelines. We work with thousands of pipelines, thousands, more than thousands, I can say. Each pipeline will have its own requirement. As per the requirement, any number of stages can be there in the pipeline. Like there could be code coverage, code scanning, there could be build, Docker image, vulnerability scan, so many can be there. Okay, so those stages should be included, means developers should have those plugins, those things configured in the POM file. Okay, those are not related to developers, sorry, DevOps person. According as per the requirement, developers will add those things, dependencies in the POM file. Like you are able to run MVN test, you will be able to run those commands or goals. Okay, you don't need to configure those stages. If those stages are there, yes, they'll be executed. Like unit test we did, right? Similarly, because test cases are written, because those goals or the plugins were configured in POM file, you are able to run MVN test. That's unit testing. There might be integration testing. There might be code scan stage. There might be code coverage stage. There might be code review, right? These are all, if developers are configuring them in the POM, you will be able to execute that the pipeline. So you have nothing to do there. But yeah, those comes with the POM file, the build automation tool. You'll be given with the goals. Okay, you don't need to get into that part. We'll not go. We will not go on loans on our cube and all, not required.
Okay.
And also, like if code review, there are hundreds of plugins. PMD, Program Mistake Detector, find bugs, so many are there. That should be first configured in the POM file. And the goal will be MVN, PMD colon PMD, some goals. Those should be provided by developers. Then you run that stage, yes, code review happens and you get the report. But you don't need to go and learn this program mistake detector, how to put it in POM and all. So you don't need to worry about it. Yes, those stages will be there in the pipelines.
Yeah, nowadays in DevOps responsibilities, that is Sonar Cube, Nexus, all those, they are also
Just an
asking.
idea, like you have some idea on Maven, an idea of Sonar Cube will do. When you see the pipeline, you'll understand it. But if they're expecting in-depth of Sonar Cube, I believe we are not into it. But if you are interested, you're already from development background, you know Sonar Cube, you fit into that. If they are expecting in-depth of Sonar Cube, generally that's not our DevOps thing to learn Sonar Cube in depth. You understood what I'm saying?
Yeah, got it.
Like
But
people,
yeah,
some might be in the test environment, testing as a previous background. They know it. They may fit into it, or if they are expecting in-depth knowledge with those tools and all. But as a DevOps person, an overview is fine. When you walk through the pipeline, you will get it. You don't need to learn those separately. Nexus anyway, yeah, it's a push thing. Like particularly with respect to containerization thing, you push the same way to Nexus. But I'm not teaching that separately as a topic, with the idea that if you know pushing these things with a little exploration, you can do that also.
okay.
All right, then I'm closing here today. We'll continue tomorrow from here. Thank you all. Have a good day. Bye, everyone.
Thank you.